All right, so we have the weight of the water we need, the weight of cement, the percent air, and the coarse aggregate. So all that's left is the fine aggregate requirements. To do this, we're going to use the absolute volume method. So what this essentially does is it turns these weights into volumes, and for 1 cubic yard, we can subtract out um, what's taken up by these, and what's left over is going to be our fine aggregate. So I've started this off with um, converting the water to from a weight to a volume, and of course to do that we need the unit weight. So for water, that's 62.4 pounds per cubic foot. So we have 240 pounds per cubic yard divided by 62.4 pounds per foot cubed, and that gives us 3.846 feet cubed per yard cubed. So we can do that with the cement as well. For the cement, it's going to be 564 pounds per yard cubed divided by, in this case, we have a specific gravity of 3.15 for the cement. So that's going to be 3.15 times the unit weight of water, which is 62.14 or 62.4 pounds per foot cubed. And that gives us 2.869 feet cubed per yard cubed. In the case of the air, we have 6%, so we'll do 0.06 per yard cubed. And that's going to be divided by, is it going to be divided by? How does that work? Nope. So it's going to be multiplied by 27 feet cubed. So it's going to be 1 yard cubed. So it's 0.06 of 1 yard cubed per cubic yard. So, yard cubed. So you multiply that yard cubed by 27 feet per cubic yard, and that gives you, let's see, 1.620 feet cubed per yard cubed. Now, coarse aggregate, do it just like we did with cement. So we have 2,430 pounds per cubic yard divided by the specific gravity times the unit weight of water, pounds per foot cubed, and that's going to give us, let's see, 15.135 feet cubed per yard cubed. So if we total these up, we get 23.470 feet cubed per yard cubed. And of course, we want this for a total of 1 cubic yard. So we're going to take 27 feet cubed per yard cubed minus this 23.470. Trying to keep units all the way through. And the fine aggregate volume, which is going to be what this difference is, will be 3.530 feet cubed per yard cubed. And now to get the weight with this volume, we go back. So instead of, so we went from the weight to the volume, and now we're going to go from this volume back to the weight. So we'll take, let's see. So the fine aggregate, the weight of the fine aggregate is going to be equal to this volume, 3.530 feet cubed per yard cubed, times the unit weight, which is given to us as 2.54. Or sorry, what is that called? The specific gravity, times then the unit weight of water, which is 62.4 pounds per cubic foot. The feet cube cancel, you'll get pounds per cubic yard like we have over here. And in this case, the fine aggregate is going to be equal to 559 pounds per cubic yard. So now we have all 5 elements, and in the next step, we're going to look at correcting the moisture conditions. And to do that, we're going to look at the moisture content of the coarse aggregate and fine aggregate. For coarse aggregate, it's 1%, and it has an absorption of 0.1%. And for the fine aggregate, it has a moisture content of 3.67% with an absorption of 0.2%. To get the weight, the corrected weight of these of the aggregates, you're going to take the dry weight and multiply it by 1 plus the percentage of the moisture content. So in this case, it's 2,430 pounds per cubic yard times 1.01. In this case, it's going to equal 2,454 pounds per cubic yard. And for the fine aggregate, we'll do the exact same thing. We take 559 pounds per cubic yard that we just calculated and multiply it by 1.0367, which is going to correct for that, the moisture. And that's going to equal 580 pounds per cubic yard. Now, here's the thing. When you change the weight, when you change this these values right here, you're adding water to these values. So what you need to do is you need to take some of the water out of the water that you would be putting into the mix. So when we correct for water, we're going to take what we had originally, which is 240, and we're going to subtract the weight that went into the weight of this of the aggregates. So we're going to subtract this original weight we had, 2,430 pounds per cubic yard on that coarse aggregate, times the absorption as a decimal, so 0.01 because it was 1%, but minus, the moisture content, but minus the absorption, which is 0.001. And you can see that when you have moisture content, the moisture content's along with the aggregate, but the absorption is going to be absorbed and taken out of the mix. So that's why you subtract the moisture content, and ultimately a minus of a minus, you're adding the absorption. So we'll do the same thing for the fine aggregate. We have 559 times 0.0367 minus 0.002. You come up with 199 pounds per cubic yard of water. And from here, that's the end. So we have a summary of the values. And essentially you just say that the ingredients would be for 1 cubic yard of concrete. Because we have them in pounds per cubic yard, it makes it much easier. So for water, it's going to be 199 pounds. For cement, it's going to be 564 pounds. For fine aggregate, it's going to be 580 pounds. For coarse aggregate, it will be 2,454 pounds. And the admixture, if you remember from way back 5-10 minutes ago, is 5.1 fluid ounces. So that's the end of that problem. Thank you for watching.